So welcome everybody. Before we get started, I would like to pay my respects to acknowledge the traditional owners of the land in which we all meet, each individually meet today, and pay my respects to elders past, present and emerging. So today we've got two speakers who are going to talk about the effective management of water infrastructure assets. This is a real critical challenge that we have in my own organisation at Sydney Water. It's one of those things where we it's a challenging and dynamic environment, and we really know that we need all the tools and resources that we can get to help us manage kind of different water infrastructure assets. And so without further ado, I'd like to introduce you to Marjorie Valix from the University of Sydney and Jason Goode from WASA, who are going to present to us a discussion on the effective management of water infrastructure assets. So I'm going to hand over to the speakers. If anybody has any questions, please put them in the chat. We will make some time at the end for Q&A, but if you put them in the chat, we can ask them as it goes along, so you won't forget them. So over to you, Marjorie.
We're starting with James.
Oh, sorry, over to you, James.
To give the context.
My apologies.
Thanks,
my apologies.
Well, good afternoon, everyone. My name's Jason Goode. My title with the Water Services Association is the Asset Program Manager. My role, what that really means in effect is my role is to try to improve asset management processes and throughout the industry. I've been with WASA for 6 years. Before that, I worked in a variety of water companies, and mainly Yarra Valley Water in Melbourne, where I worked for 14 years. So this won't be news to anybody on the call, I don't think. The water industry manages a wide range of varied assets. We have dams that can fail catastrophically, like the one in the picture, all the way down to, there's parks, there's drainage pipes, there's sewerage infrastructure, there's treatment plants, and probably at the other end of the spectrum, I've got a picture of a water meter there. So even things as small as water meters, which if they fail are not probably the end of the world, but certainly can have brand damage on a water company if our water meters aren't billing our customers correctly. But regardless of the asset, and I'm happy to have a discussion on it, I'd argue the asset management principles remain the same in terms of the life cycle management, data we collect, how we make decisions on their maintenance and replacement and disposal. One of my roles within WASA is to manage an asset management network. So we get the asset managers from the various utilities across the country together, and we talk about asset management topics. These topics tend to be high level, not focusing on individual assets, but on the asset management process. I thought I'd take you through some of the recent challenges or recent discussion topics. The first one on that list is resilience and climate change. It's been a big challenge for the industry, how we adapt to the greater impact that the environment's having on our assets, the fact that we can't make decisions based on historic information so much, and how we need to think about our network as a system. It's not just a pump that needs to be fixed. It's the pump, the pipe, the whole system that's supplying water or pumping away sewage. So there's a bit of a change for the industry in that regard. Data and analytics is a massive one. And that you're going to see that's going to come up again and again in my presentation. And it's possibly more relevant to this group. There's huge scope for us to make better decisions with our data that we collect on our assets and how we analyse that data. Culture is the third one I wanted to raise. It's kind of linked to the data piece, But a lot of people who work in asset management are engineers. They're not necessarily the best communicators. And the other thing asset managers do is they try to drive change. In order to drive change, you really need to be able to communicate well. And I've got that picture in the bottom left about how we get sponsorship for asset management changes, how we get collaboration to help us with our changes, and how we get ownership. The fourth challenge there is growth. Population growth remains a challenge for the water sector, and this consequently creates challenges for asset managers. There's a real conflict between money that's invested to service growth compared to money that's invested to maintain the existing system. And what we hear time and time again is money is diverted from maintaining the current system to service growth. My last dot point there is asset management maturity benchmarking. That's one of the key projects the Asset Management Network has been doing, and I want to take you through that in a bit of detail later. How much time have I got, Leigh? Have I got another 5 or 10 minutes, or I'm already feel I'm going over time, but I'll keep going.
Good question. No, you can keep going, James.
To some of the more practical type groups, we also have a civil assets community of practice, and that's where we get a bit more focus on the actual assets. So you can see what some of the things they're working on. There's been a real focus on better decision making in the sewer network. There's a real opportunity there that's been acknowledged by the industry. There's a lot of data we have on the sewer network, a lot of possibilities to get better data. So the real opportunity to manage our networks better. And the other thing that we're focused on is water quality at tanks. It's a fairly specific item, but again, the same issue. We've got a lot of data, we can do a lot better. Another specific area of interest is dams. And they're certainly looking at managing that extreme consequence low likelihood risk, but they're also looking at how we can get better sensors. Dams are often in remote areas, takes time to get out there. So they're looking at much better real-time data for their decision making. And across the industry, we're seeing real challenge with increasing costs and resourcing. And so if we can get better information on our assets and extend their lives or be more effective in where we repair, then that's going to make a real benefit to our sector. I'll fly through this. People can ask me questions if they like. We did do benchmarking, and I want to take you through this. 21 utilities benchmarked themselves on asset management. And what we did is we looked at the business outcomes and then map those to elements of asset management. And you can see the framework for asset management on the right-hand side of the screen. So those 6 key areas on the right, strategic and planning, life cycle delivery, decision-making, organisation people, asset information and risk and review are kind of the areas we looked at. So this is hot off the press. This is only just released in October. So this is the box and whisker plot of how we're doing asset management in the industry across those 6 key areas. I guess the other thing to point out in this chart is the score is from 0 to 2, with 0.75 being a pass mark, competency. The key things to note, we do really well as an industry in strategy and planning. We do very well with our people. We do pretty well on risk and review and continual improvement. The key thing to note is asset knowledge. On average, we're not competent. We don't do this well. And I'd argue that then feeds into the blue and the green. Because we haven't got this 100% asset knowledge 100% right. It means our decision making is not as good as it could be, and our life cycle delivery is not as good as it could be.
So James, can I just ask a quick question about that?
Yep.
When you say asset knowledge, what do you mean by that?
Okay, I'll go into the subjects, but there's four key areas for asset knowledge. There's your information strategy. There's the systems you use to collect asset information. there's how you manage it, and then there's the the actual data information that you're collecting. And I'll go into this. I'll quickly go past this slide. The key thing here is to show that we have actually improved in 4 years. When you do a breakdown, each of those 6 areas has actual subjects underneath it. And so you can see the purple ones, which is the asset information. And the one that we're worst at as an industry is asset information management. And this is specifically things such as, I made a note of this, things such as standards for information, controlling who has access, the quality of the information we're collecting, security of the information. These types of things we have to really improve on. So you can see some other things that resourcing is also a big issue for the industry at the moment. Probably won't go through this in detail, but we did survey the industry on the business outcomes that they're most keen on seeing, and health and safety is the most important, the reliability of service provision. So we're trying to work out how asset management delivers these key things. And that fed into some targets for these 6 areas. And what you can see is for asset knowledge, we want to be way up here, where this blue dot is, and we're way down here. It's probably only strategy and planning where we're hitting where we need to be. But it's really this asset knowledge area that we have to work on as an industry. And again, you can see that in comparison to where we want to be, it's this asset information management of change, and how we monitor our asset performance are really key areas we have to work on. We did ask some questions about some key areas such as safety, community needs and expectations. You can see we're doing pretty well. We're not doing so well in addressing climate change, digital assets, or making decisions based on our data. They're probably the key areas that we need to work on. So that's it. That's an overview of asset management in the water sector.
Thanks,
I can go into a bit
James.
more detail if you like, but that's I didn't think I had a huge amount of time to speak.
Yeah, thank you. And I have one quick question, which is, can people access the report?
So WASA will prepare an industry report. Well, our consultants will on our behalf, and that will be available to the whole industry. Yeah.
Great, thank you. Just go out to the audience. Does anyone have any questions for James about what he's just presented? No?
Not
I have
so
more
much a question. Sorry.
Yep, go.
Not so much a question, but more a agreeance about. Absolutely, I think asset knowledge is fundamentally a key area that a lot of our, not just utility sectors, actually, even local governments and government sector are contending with. And it's not just asset knowledge, but it's actually the management of that knowledge as well. So if someone who has been working in this industry for a while and all of a sudden they retire, like you've given a lot of examples of dams, and a lot of these dams were built by engineers back in, like last centuries, and they've definitely, now gone ahead and retired. And to retain that configuration of how that asset was built and going on to managing that, I have personally and professionally found that to be the most difficult part as well.
Just there's the retention of knowledge, but even I've been talking about this for a while now, making decisions about what knowledge we actually need, and people would have heard about this a lot. Understanding the value of the data that we collect has been something that is not new to I'm sure anybody on this call, but we still don't do it very well. What data should we be collecting? Because data, even though it's getting cheaper, it still costs a lot of money. So we should be very careful about all the data we collect and making sure that it is creating real value.
Yeah, thanks, James. There was a question, was the assessment of maturity based on the ISO 55000?
Okay. So ISO 55000 is a standard. It's more of a compliance standard that people audit themselves against with their asset management system. I'll just go back to this slide. This framework, it's for the Global Forum for Maintenance and Asset Management, and the 39 subjects that underpin it, they go beyond compliance. So there's a lot of, it's all aligned to ISO 55000, but it goes beyond 55000. So it looks at where's excellence, what's good practice, not just compliance.
Yeah, thank you. I have probably a bit more of a comment, and I'm assuming that there are some potential researchers or people from academia in this call, and it was a comment that you made that not many people are looking at climate change, and also we can't. What we've been doing is looking at past data, and we all know that it's not a good predictor of future scenarios. And so for me personally, I think there's a real opportunity there to think about how we are going to manage our assets, effectively manage, not just with the data, but how we utilise that data into the future and using climate change models and things like that. So I'm just going to put that there. I like to leave little potential research projects there for people just to consider. We do have...
Can I just clarify that point before you move on?
Sure.
So that slide here where I've said that what this is measuring is how well asset managers are actually addressing the climate change issue. And so I'd probably suggest that a lot of the water industry, and Leigh, you might argue with me, is actually taking the climate change challenge on board and is looking at it a lot. I just don't think we've quite made that progression to getting into our asset management systems and our decision-making tools just yet.
Yeah. And that's the point. How do we get those climate models into that sort of asset management space? Ish, You've got your, I'm sorry if I've said your name wrong, but you've got your hand up.
Yes, yeah, me again, sorry. This is a part of my role that I have a lot of passion about. In regards to climate change and the respectful inclusion of Indigenous leadership and elderly knowledge is a profound research area that I would love to have a dissertation myself, but there's just so many questions as to how we can best, without further extracting from those communities, but how to utilize historical evidence-based land management practices as to how our infrastructure assets can then thrive in the impacts of climate change, whether it's material, whether it's gentle soil stabilization solutions. It is such a big scope, but yeah, so it's not so much a question. I just wanted to add to that as well.
Thank you. James, did you want to comment to that? I think if you're talking, I think you're on mute. No? Okay.
No, sorry, I was thinking. We did explore how we've, you can see Indigenous aspects was something we did explore and how that's been incorporated into our asset management. And generally they've said they're doing okay. I don't think that is a reflection of what Ish just mentioned. I think it's probably more around the consultation and involvement in our capital works programs, but actually learning from Indigenous cultures and how we should better manage our assets is an interesting area to explore.
Thank you. Okay, keeping an eye on the time, I'm going to hand over to Marjorie Valix, who's going to run us through her presentation I am just going to turn my camera off and go and try and find some power for my computer because it might. So I'll be here, but I'm just going to go and try and find power for my computer.
Okay, thanks, Leigh. So what I'd like to do is just talk briefly about, I guess, one of the work that we've been trying to go through with support of Smart Grid CRC. And this is the development of risk-based decision tool for management of assets in the water sector, and specifically focusing on optimizing maintenance, replacement, and risk mitigation for aging infrastructure. Okay, so I mean, James has already gone through this quite well, so I'll sort of like skim through this. But essentially, the water sector, as we see, is facing a lot of, I guess, increasing challenge, particularly due to aging infrastructure. Much of the assets that we're talking about, our pipes and treatment plants, had been constructed perhaps maybe something like 80 to 100 years ago. So this not only leads to obviously service disruption, but also creates environmental risks, which drives up maintenance costs. Now, one of the issue obviously of the traditional management method is that it often relies on very simple metrics, for example, asset age and performance, because these are readily available. So while these metrics are usually fairly helpful, they often don't capture the full picture. So for example, they might not fully account for the actual full risks and also the potential consequence associated with if the asset actually fails. So the role of an RBT, or a risk-based decision tool, is more to provide a framework by which the utilities can actually develop a risk framework for the facility to assess essentially the risk based on the likelihood or the chance of the asset failing, and also the potential consequence of that failure. So just to make it more explicit, what do we mean by a risk-based decision tool? So again, it's really just a framework by which the utilities essentially tries to capture the risk profile among its asset cohort by looking at the chance of the failure of that asset and also the impact of that particular failure. So the key features of a risk-based decision tools often involve the risk calculation. Again, just reiterating, it's just the likelihood of failure and consequence of failure, and prioritization by essentially looking at the different the risk matrix associated with those assets. It can also deliver things like cost effectiveness analysis by enabling the utilities to evaluate the cost option of, for example, repair or replacement. And they can also do things like scenario analysis, for example, when considering things like the aging assets, or perhaps even, for example, let's say climate change and the impact of that. Now, the key focus of the work that we're doing, although we know there are already resource-based decision tool, is I guess to push the idea of evidence-based decision tool. So the reason why we, before I do that, evidence-based decision tools essentially are service life models, which are built on understanding of the mechanisms of failure, including physical, chemical, and kinetic models. Now, question is, why would you actually need an evidence-based decision tool? So what we can see is that the current challenges with the current RBT is typically around data availability and quality. We know that current RBDT rely on data such as asset performance, failure history, environmental factors. But sometimes if we look at this, some of the data are often incomplete, they're inconsistent and inaccurate, and often they could be outdated or fragmented. So what we're really looking for is that to improve RBT, we need to have a much higher quality and also real-time data. The other aspect is the complexity of the models. I mean, the processes themselves are that involved in, for example, deterioration are quite complex. And then we're actually having to deal with multiple variables, for example, the age, the type of assets, the type of material construction, the condition, maintenance history, operational loads, so on and so forth. So it can actually be quite complex to try and understand these processes, and particularly the interdependencies of these variables. So what we really need to have here is an evidence to essentially back up what we think or what our gut feel is actually happening, and essentially to validate the risk models and therefore improve the accuracy of the predictions. The other aspect is the uncertainty around predicting future events. And I guess we've already touched on the fact that we have climate change here. So if we're relying on data or historical data that we've never, where we've never had experienced climate change or the impact of climate change, then how can we actually predict that? Having an understanding, or much more, I guess, rigorous understanding of the processes involved will actually help us to manage this uncertainty, because it actually builds on backed up evidence about how these processes actually occur in the first place. And so the lack of root causes of deterioration can actually be challenging for current RBDT, because they're actually unable to predict them very accurately. So the idea for evidence RBDT is actually to improve the accuracy and the reliability of the models. So evidence-based framework, so this is essentially how we look at this. So we're looking at asset criticality. So currently we use either statistical data around past failures or physical models by comparing failure, stress, and resistance. Our focus is really more to look at deterministic type models, which forecast the failure based on chemical and corrosion kinetics. And that provides us with the likelihood of failure. And then using the consequences that's usually developed by the utilities, develop a risk matrix, and from there create the decision alternatives as part of the overall asset management plan. Now, another way of actually putting this deterministic model is to look at it in terms of what we call a dose response method. So dose means we're looking at, well, what causes the deterioration. So that looks at the environmental condition, but more importantly is actually trying to classify the risks associated with those environmental conditions. So for example, a low H2S environment compared to high H2S environment, how would we classify that? The response essentially will how the actual asset responds to those doses. So for example, by looking at the deterioration mechanism, the actual condition of the asset, either from the field or from accelerated corrosion lab tests, we're then able to develop, I guess, an asset performance sort of model or service life model. Using usually kinetic modeling or physical modeling, computational fluid dynamics, and machine learning to try and capture that dose and response, I guess, interaction. Now, so if I can just, for example, use this as an example for the sewer environment, we know that the gas phase resulting from microbiological activities actually contributes to the corrosion on the gas phase of most sewer pipes. And what we've done here, now previously there was only one classification for the corrosivity of the sewer assets, where it was simply considered as extreme environment. And part of the work that we've done essentially is by looking at through various types of assets in Australia, and also doing surveys of environmental condition followed by condition assessment. We've come up with, I guess, a set of classification, which essentially classifies the risk associated with this environmental conditions based on the gas concentrations, H2S and CO2, the temperature and relative humidity. And then by providing a classification from C1 to C5, where it ranks that between very low to very high corrosion impact. And from that, we can also predict the OPC depth of corrosion based on the relative corrosivity. And what we've done too is that we've actually verified this corrosivity rating by essentially installing different type of other non-OPC material in this different environment. And then to verify whether the relative corrosivity that we've observed here is consistent. And what we can see is that it is consistent. So this I'll just give you some examples in terms of actually how we've also compared the reliability of some of our deterministic model. So this one is again for concrete acer in sewer gas phase, both from the high end and also the low end corrosivity. So what this data is actually compares the actual service life in the field compared to the predictive model. And so although there's still quite a huge variation between what we would expect and what we would actually model, or what we would actually predict by a model, it is going through the right sort of trend, in that as we increase the service life, we are also seeing an increase in the service life that we actually predict. Another, area that we've been also focusing on is the impact of soil corrosivity. Now, soil corrosivity has largely been ignored in the water sector. But what we are noticing is that, for example, from a comparison of this work, is that where we compared the impact of soil corrosion to the gas phase corrosion, we could see that the rate of corrosion from the soil is actually much higher in some instances compared to the gas phase corrosion. Now, by looking at this again, by modeling this using our deterministic model and comparing again various failures of assets that has been impacted by soil corrosivity, so we could see again that the predicted life is quite consistent with the actual measured life. So the original modeling that we've done was using the blue line, and the orange dot is our verification whether the model is actually working. And part of the work that we're also trying to do is to actually now start mapping these type of data and service models using the GIS. So essentially, the GIS gives us an overlay of the service data, and it allows us to, develop almost like a heat map, or allows us to identify the areas of asset concentrations where there's a high risk of failure. And in a way, this also enables us to also verify whether our assumptions about the impact of corrosion, or the dose impact on the corrosion, is correct. So for example, for this particular study, we're looking at the impact of pH, of the soil pH. And for example, the green here is where the soil pH is greater than 7, and the orange is where the pH is more around between 2 to 5. And if we had then overlay the actual assets which have failed in less than 44 years, they are consistently within the area which is highly acidic soil, whereas those assets which have failed after 94 years, we could see again they're concentrated in the region which are obviously less acidic, which again confirms the impact of soil corrosivity. Okay, so what we could see here is that there are benefits to the evidence-based decision tools. So what we could see is that there's more accurate and context-specific assessment. Essentially, the precise evaluation based on real-time data and specific asset condition can lead to better prioritization of resources and provide a much more targeted intervention. And we could also see here that although the traditional, RBDT method focused on more static and also historical failure data, we could see that evidence-based tool can actually enable the integration of new data. And what that means is that it allows the utility to essentially proactively, improve and increase the robustness of that of those tools. And they're able to therefore predict and prevent asset failure before they actually happen. And so this shift, from a more reactive to proactive maintenance reduces the downtime and long-term costs. The other aspect is the actual enhanced transparency and justification. Now, if we have an RBT which doesn't rely on evidence base, it's actually very difficult to justify why the actual failure occurred. So by having this, it offers a much clearer rationale for utilities to enable them to make their decisions. they're able to provide, I guess, a better way of communicating with stakeholders and regulators, because the evidence or the information they're actually providing is based on clear and data and evidence-backed explanation. So I'd just like to acknowledge our partners, which are the following utilities and also the WASA. Okay, thank you.
Thank you so much, Marjorie. It's so interesting. Does anyone have any questions about the presentation? I can see myself. Yeah, great. Good.
Yes, thank you very much, James and Marjorie, for your presentation. I have a couple of questions for Marjorie. Firstly, you talk about the environmental condition, the gas phase, looking at the hydrogen sulfide and also carbon dioxide. I'm not quite sure what the CO2 role there is. That related to carbonation-induced corrosion or something else?
Yes, it is. So essentially, previous studies have really attributed the corrosivity only to H2S. And that sort of makes sense because it's essentially the precursor for making sulfuric acid. But we also know that in order for the microorganisms to get to the state where they're producing or essentially converting H2S to sulfuric acid, you need to actually reduce the pH of the concrete, in which case the carbonation is quite important as a first step. So, and then after that, really need to look at both the contribution of both the sulfuric acid and carbonation at the same time, because they actually interact with one another. Initially, CO2 was pretty much ignored because it was assumed that it had very low corrosion impact compared to sulfuric acid. But what we can see now is that they actually interact together, and that the dynamics between the two has to be taken into account.
Thank you. My second question is the external soil corrosivity. I do understand the effect of sulfate and acid condition in the soil that obviously affect the deterioration of concrete. My question is that I understand that when we lay our pipe, the quality of the backfill material is quite important. In other words, the backfill material must not contain, I guess, high sulfate and so forth. So I thought that would have reduced, I guess, the effect of the external sulfate and acid affecting the external deterioration of the pipe. Can you comment on that, please?
Yeah, sure. Actually, when they lay the asset, they do make sure that the soil itself is not corrosive, so they don't deliberately build on a soil which is highly acidic. But the problem that you've got now is that because of the changes in the water tables, they're actually shifting the acidity to different location. So that means, well, once the asset is laid, it can obviously be reshifted. So this is the problem. Essentially, the soil corrosivity around Australia is changing because of these changes in the shift of the water levels, particularly in certain states.
Thank you. And my final question, sorry, Leigh, I got too many questions. But the third question...
They're all good ones.
The third question is that with any aggressive environment at all, the work that we do in looking at concrete structures is that the stress condition actually can make things worse. And in a typical concrete pipe, for instance, I think it's probably not too difficult to work out what is the stress condition in the different parts of the pipes. And therefore, that may dictate the severity of those aggressive environment, whether it's hydrogen sulfide or sulfate and so forth. I wonder whether that you've seen any evidence of that.
We haven't actually looked at the impact of the soil load on the actual asset itself, although what we do is we do monitor, although I've only provided the depth of corrosion as one of the measures, but one of the factor that we actually also measure is the remaining compressive strength of the asset. I suspect that I think an area of research that really could be looked at is the impact of the load on, in addition to actual corrosivity, because at the moment when I've actually asked the question, what would be considered to be, I guess a remaining compressive strength when the asset would be considered to have failed. And actually that's a very difficult sort of thing to answer because no one has the answer. We had been looking at some work by Ian Moore. He's in Canada and in Queen's University, where they actually look at this type of failures and problems, but they have a very specific lab where they actually they can bury pipes and they can actually put different loads on it. We don't have that facility in Australia currently, but it would be good to actually have one because that would enable us to further understand this kind of problem you're talking about here.
Thank you very much, Marjorie. Thank you, Leigh.
Yeah, thank you. Good questions, Vu. Does anyone else have any questions about the presentation? Does anyone have any comments about either challenges that you're facing or potential research opportunities, or like this is a community of practice and it's a really good platform to be able to identify opportunities. It's just so there's a comment by Christopher saying, yes, remaining compression strength and tensile strength left in RC pipe due to deterioration condition would be useful in determining the EEOL of an asset. Harry, you've got your hand up.
Yeah, thank you. And thanks for the presentation. Sorry, I wasn't available for the full presentation. I certainly missed and I have to catch up later. Probably maybe comments or questions is that my understanding is that, for instance, for AC pipe, it doesn't normally deteriorate in a uniform way. You see spots that it's more deteriorated and less deteriorated. How can we really attribute this modeling to those sort of behavior of the pipe that doesn't uniformly corroded when we know that the corrosion should have similar effect on the pipe? I'm not sure if the same for the concrete. Have you noticed that in sewer aspect, for instance, when it's closer to the axe maintenance hole, is it less vulnerable to the corrosion than further into the pipe? Or do we know that for external corrosion, I noted that the depth of the soil assessment was, I think, 200 to 300 millimeter, which is well short of the depths of where the pipe sits in. Would that accurate representation of what's the pipe actually sitting in environment that represented from the topsoil, let's say? And I noted also that those pipes that had higher corrosion were further inland. That probably suggests the water level is lower. And so perhaps maybe it's the anaerobic condition of the soil that impacted to the corrosion. So there are some, it's not like a really question, it's like a lot of topics to discuss and consider.
Yeah, so if I can get this right, if I start with the first part of the comment, so you're right that, for example, in the pipe itself, the corrosion is not uniform, and so that's why we tried to develop the classification of the corrosivity of the environmental condition, because if we can map the environmental condition, that can then be used to infer directly the relative corrosivity of those environment, and then at the same time, that could then be used to develop the rate of corrosion across the pipe itself. Because it's actually a very difficult thing to even say do a condition assessment. Otherwise, you do a condition assessment on the whole network, which is impossible. But having an idea at least of what how to infer those corrosivity rating would actually enable you to kind of map across the pipe what you'd expect it to be doing. The other part about the placement of the pipe, I guess geographically, is it? So yes, so whether the corrosivity will change associated with where the location is. So the idea behind the actual modeling that we're trying to do is to actually use the geoscience data for the different soil sort of rating and use that as part of our predictive tool. But what we have to do first, though, is to try and develop the model and then use the current data that's already out there based on geoscience data and other sort of platforms to try and build some sort of an idea of predicting sort of like the relative corrosion. But having said that, we can do this, but I think we still need to do a lot of verification as well. And part of that is to then work with the utilities to verify whether what we're saying is correct. And that means that the relative corrosion that we are inferring from our model is actually being correctly reflected by doing all those condition assessment. Does that cover at least part of the question or comments?
Yeah, thank you, Marjorie. Yes.
Okay, thanks. Good question, Harry.
Yeah, good question. Any other questions? Any other comments? I feel like Voot's got a question.
No,
No, no pressure.
I felt that what James and Marjorie have enlightened us today has been most useful. I think James point out to the fact that some of the most challenging fact is that we do not have sufficient data on I guess the environment condition and so forth. And from Marjorie's presentation, obviously we can see the complexity of those unknown or those variable, I guess, on the performance of some of these assets. So I really benefit from this particular community of practice. So thank you very much, both James and Marjorie, for your presentation.
Thank you. Yes, thanks, Voot. Yes, so James, thank you so much for your presentation. I look forward to seeing the report that you guys are going to release in regards to what you've presented. And Marjorie, I'm quite keen to follow up on that. I noticed that there was a paper attached to one of those slides. I'd be quite keen to look at that. Sydney Water has been working in this space a little bit, but it'd be good to see if there's any synergies in what you're doing or in approaches. We do look at soils and soil moisture and things like that. But I do think that as an industry, we can improve in that we do collect a lot of data. How do we look at that data and really not just leverage it, but, you know, give it power to make really good decisions in the future? I think we need to start thinking about that and pretty quickly. Does anyone have, I'm going to close off the meeting and give people time back in their day, unless anyone has one last comment, question. A very big thank you to our presenters, James Goode and Marjorie Valix. Thank you so much. I always learn so much from these community of practices. I look forward to seeing everyone probably next year. Next year? Yep, perfect. Can I say it now? Is it too early? Have a really good Christmas break. We're all racing towards it. So I hope you have all a relaxing break, and I'll see you all in the new year. Thank you.